Long before telescopes or satellites, our ancestors gazed at the night sky and witnessed things they couldn't explain. Imagine standing under a sky so dark and clear that the stars seemed close enough to touch, only to watch as a new light suddenly blazed among them, brighter than anything you'd ever seen. Or picture the terror of a day when the sun vanished without warning, plunging the world into darkness at noon. These weren't just stories, they were real events, seared into history by the people who lived through them. From supernovas that outshone the moon to comets that foretold the rise and fall of empires, ancient skies were alive with mysteries that still baffle us today. Over the centuries, these celestial wonders shaped religions, inspired legends, and even guided the course of science itself. In this journey, we'll uncover 50 of the most astonishing astronomical events recorded by ancient civilizations, events so strange, so awe-inspiring, that they blur the line between myth and reality. By the time we're done, you'll never look at the night sky the same way again. So keep watching, because what comes next might just rewrite everything you thought you knew about the cosmos. Now, let's turn our gaze to one of the most debated celestial events in history, the Star of Bethlehem. Described in the Gospel of Matthew, this mysterious light guided the Magi to the birthplace of Jesus, but what exactly was it? Some scholars argue it was a comet like Halley's, which blazed across the sky around 12 B.C. Others point to a rare conjunction of Jupiter and Saturn in 7 B.C., creating a brilliant spectacle that ancient astrologers would have seen as a royal omen. Then there's the theory of a supernova, a star exploding with such intensity it could have been visible even in daylight. But beyond the science, the star's legacy is undeniable. It shaped art, inspired countless nativity scenes, and became a symbol of divine guidance across cultures. Whether a miracle or a cosmic coincidence, this celestial beacon remains one of history's greatest astronomical puzzles. Shifting our focus from the skies to the sea, we uncover another marvel of ancient astronomy, the Antikythera Mechanism. Discovered in a shipwreck off the Greek island of Antikythera in 1901, this intricate bronze device has been called the world's first analog computer. At first glance, it might look like a corroded lump of metal, but X-ray scans revealed a stunning truth. Gears within gears, precisely arranged to predict celestial events like eclipses, planetary positions, and even the timing of the Olympic Games. The level of engineering is mind-boggling for something crafted around 100 B.C., centuries before similar technology appeared in medieval Europe. Who built this masterpiece? Some point to the legendary inventor Archimedes, though the mechanism dates to decades after his death. Others suggest the workshop of Posidonius, a Greek philosopher known for astronomical studies. But here's the real mystery. If the ancient Greeks could create such advanced technology, why have we found no other devices like it? Was this a one-of-a-kind wonder, or are there more lost treasures waiting beneath the waves? The Antikythera Mechanism forces us to rethink what we know about ancient science. It's a haunting reminder that history's greatest discoveries often lie hidden in plain sight, waiting for the right moment to reveal their secrets. Now, let's journey even further back in time to witness an explosion that lit up the ancient sky, the Crab Nebula Supernova of 1054 AD. Imagine a star so bright it outshone the moon, visible even in broad daylight for nearly a month. That's exactly what observers witnessed in the summer of 1054 AD, when a massive supernova explosion lit up the sky, an event we now know as the Crab Nebula. Chinese astronomers of the Song dynasty left meticulous records calling it a guest star that appeared near the constellation Taurus. They noted its dazzling brilliance, describing it as visible during the day for 23 days and at night for almost 2 years before fading from view. Arab scholars like Ibn Batlan also documented the phenomenon, comparing its sudden appearance to a celestial omen. But here's where it gets even more fascinating. Halfway across the world, Native American cultures may have captured this cosmic spectacle in rock art. Petroglyphs found in what's now the southwestern United States show a star next to a crescent moon, a configuration that matches the supernova's position relative to the moon on July 5, 1054. Could these carvings be an ancient snapshot of the event? While we can't say for certain, the timing and alignment are eerily precise. What makes this supernova truly extraordinary is its legacy. Today, the Crab Nebula is a sprawling cloud of gas and dust, still expanding from that cataclysmic explosion nearly 1,000 years ago. At its heart lies a pulsar, a spinning neutron star that beams radiation like a cosmic lighthouse. It's a reminder that the universe's most violent events can leave behind breathtaking beauty, and that our ancestors, separated by continents and cultures, all looked up in awe at the same celestial wonder. Now, let's turn our attention to a different kind of darkness, one that swallowed the daylight in ways no supernova could. The mysterious dark day of 1780 and its possible echoes in even older texts. Now, let's step into a mystery that turned day into night, a phenomenon so unsettling it left entire communities in awe. On May 19, 1780, parts of North America experienced what became known as the Dark Day. By midday, the sky grew so dark that candles were needed indoors, birds fell silent, and flowers closed as if night had arrived hours early. Witnesses described an eerie, smoky haze that blotted out the sun, with some even fearing the end of the world. But this wasn't the first time humanity witnessed such an event. Ancient texts hint at similar occurrences. Egyptian records speak of a day of darkness during the reign of Pharaoh Ahmose, possibly linked to the volcanic eruption of Thera around 1600 B. CE. Mayan inscriptions also reference unexplained periods of darkness, often interpreted as omens or divine messages. Could these be echoes of the same natural forces at work centuries later? Science offers compelling clues. The dark day of 1780 likely stemmed from a perfect storm of wildfires and atmospheric conditions. Massive forest fires in Canada, possibly intensified by drought, pumped smoke high into the air, while a temperature inversion trapped it near the ground, creating that suffocating gloom. Similar mechanisms might explain ancient darkness events, with volcanic ash or comet debris playing the role of the smoke. What ties these episodes together is their uncanny ability to blur the line between natural wonder and supernatural dread. Whether viewed through the lens of myth or meteorology, sudden darkness reminds us how fragile our relationship with the sky truly is, and how deeply its mysteries have always resonated. Next, we'll uncover how an ancient civilization turned the motions of Venus into a celestial clock hidden in clay. Now, let's turn our gaze to the ancient skies of Mesopotamia, where clay tablets held secrets far ahead of their time. Among the most astonishing discoveries is the Babylonian Venus Tablet, a series of cuneiform records dating back to the reign of King Ammisajuka around the 17th century B. CE. These tablets didn't just note the movements of Venus, they predicted them with startling precision, centuries before modern astronomy could explain how. What makes these records so extraordinary is their methodical detail. The Babylonians tracked Venus's appearances and disappearances over a 21-year cycle, distinguishing its morning and evening phases with meticulous care. They noted how long the planet remained visible when it vanished behind the sun, and even linked its movements to earthly events like harvests or royal fortunes. This wasn't mere observation, it was a sophisticated system of celestial timekeeping, encoded in wedge-shaped script. But here's the puzzle that still baffles scholars. How did the Babylonians achieve such accuracy without telescopes or advanced mathematics? Some suggest they relied on generations of accumulated data, spotting patterns invisible to a single lifetime. Others propose they might have used geometric models, though no evidence of such tools survives. The real shocker, their predictions for Venus's cycles were off by less than 1%, a margin so slim it rivals modern calculations. The Venus Tablet also reveals a deeper truth about ancient astronomy. To the Babylonians, Venus wasn't just a wandering star, it was the goddess Ishtar, a divine force shaping fate. Their records blur the line between science and sacred text, proving that for them, the sky was both a clock and a scripture. As we piece together these ancient puzzles, one thing becomes clear. Long before Copernicus or Kepler, humanity was mapping the cosmos with a brilliance we're only beginning to fully appreciate. Next, we'll venture to the deserts of Peru, where giant lines etched into the earth whisper of another celestial mystery. Now, let's journey from the clay tablets of Babylon to the vast deserts of Peru, where the earth itself becomes a canvas for celestial mysteries. Etched into the arid plains of the Nazca Desert are hundreds of enormous geoglyphs, lines, shapes, and animal figures so massive they can only be fully appreciated from the air. These are the Nazca Lines, and their purpose has puzzled researchers for decades. Some believe these ancient markings were more than just art. They may have served as a giant astronomical calendar, aligning with key celestial events. Certain lines point directly to the winter solstice sunrise, while others seem to mirror the positions of constellations like Orion or the Pleiades. The sprawling spider figure, for instance, might represent the Orion constellation, its legs matching the angles of the stars. But not everyone agrees. Critics argue that while some alignments exist, they could be coincidental. The Nazca culture left no written records, leaving us to interpret their intentions through scattered clues. Were these lines sacred pathways for rituals, a way to communicate with gods believed to dwell in the sky, or perhaps a practical guide for seasonal agriculture, marking when to plant or harvest? Adding to the intrigue are the nearby Palpa lines, older and less famous but equally enigmatic. Some researchers suggest these geoglyphs might have been early prototypes, refined over centuries into the Nazca designs. Others propose they were part of a larger network, mapping the heavens across the desert floor. What's undeniable is the precision behind these creations. The Nazca people, without modern tools or aerial views, carved straight lines stretching for miles, curves that never waver, and animal figures with perfect proportions. How they achieved such accuracy remains as much a mystery as why they did it. As we ponder these giant desert puzzles, one thing is clear. Whether as star maps, religious symbols, or something else entirely, the Nazca Lines remind us that ancient civilizations saw the sky not just as a spectacle, but as a guide. Next, we'll uncover another celestial map, this time hidden in the carvings of an Egyptian temple. Leaving the desert mysteries of Peru behind, we now step into the shadowed halls of an ancient Egyptian temple where the heavens are carved in stone. High above the sacred chambers of the Temple of Hathor at Dendera, a circular slab of sandstone tells a story written in stars. This is the Dendera Zodiac, a breathtaking celestial map that has sparked debate for centuries. At first glance, it resembles a familiar zodiac wheel with figures like Taurus the bull and Leo the lion. But look closer and the anomalies begin. Unusual constellations mingle with Egyptian gods, while planets are depicted in positions that don't match modern charts. Some researchers argue this isn't just a symbolic artwork, it's a precise snapshot of the night sky, possibly dating back thousands of years earlier than its official 1st century BC attribution. The controversy deepens when we consider its construction. The zodiac's circular design is unique among Egyptian artifacts, leading some to speculate it was influenced by Babylonian or Greek astronomy. Yet the symbols are undeniably Egyptian, blending local mythology with cosmic observation. Could this be evidence of a forgotten collaboration between ancient cultures? Or does it encode advanced astronomical knowledge passed down through priestly traditions? One bold theory suggests the Dendera Zodiac preserves memories of a much older sky. Certain star alignments, like the position of the North Pole, seem to match the heavens as they would have appeared around 10,000 BC, a time when Egypt's civilization supposedly didn't exist. Skeptics dismiss this as coincidence or later reinterpretation, but the precision is haunting. Did the temple's priests inherit star lore from a lost predecessor culture? Equally intriguing is what happened to the zodiac after its discovery. Napoleon's scholars were so stunned by its sophistication that they literally chiseled it out of the ceiling in 1821, sending it to Paris, where it now resides in the Louvre. This act of preservation or plunder speaks volumes about how radically this artifact challenged Western notions of ancient science. As we study these star-carved stones, one truth emerges. Whether calendar, sacred diagram, or time capsule of prehistory, the Dendera Zodiac proves that Egypt's astronomers didn't just watch the sky, they sought to etch its secrets into eternity. Next, we'll encounter a mystery not of sight but of sound, as we explore ancient accounts of unexplained celestial music. Now, let's shift from the silent stars to a mystery that hums through the ages literally. While the Dendera Zodiac captured the heavens in stone, some ancient accounts suggest the sky itself once made sounds. This brings us to the eerie phenomenon known as the Taos hum, a low-frequency noise reported by residents of Taos, New Mexico since the 1990s. Described as a distant engine or a vibrating pulse, it's heard by only a small percentage of people, leaving scientists baffled. But what if this modern enigma has ancient echoes? Centuries before Taos, the Roman philosopher Seneca wrote of strange, sky trumpets, unearthly sounds that seemed to come from the heavens. In his Natural Questions, he described noises like clashing bronze or roaring winds with no visible source. Similar accounts appear in medieval texts where monks recorded aerial horns preceding celestial events. Could these be early reports of the same phenomenon? Some researchers speculate that atmospheric disturbances like plasma vibrations during solar storms might explain both ancient and modern cases. The Taos hum also finds parallels in indigenous traditions. The Hopi speak of a sacred sound preceding earth changes, while Tibetan monks use ritual horns to mimic what they believe are cosmic frequencies. Even Aristotle mused about singing stars, suggesting ancient cultures were attuned to celestial acoustics we're only beginning to study. Yet the mystery deepens when we consider modern investigations. Despite decades of research, no definitive source for the Taos hum has been found. Some blame underground vibrations or industrial equipment, while others propose more exotic theories like secret military experiments or even extraterrestrial signals. But the most intriguing possibility, that these sounds are natural phenomena, rare but recurring, documented across millennia. Whether vibrations from Earth's magnetic field or echoes of long-forgotten cosmic events, the Taos hum reminds us that the sky's mysteries aren't always silent. Next, we'll journey to the Southern Hemisphere, where Aboriginal oral traditions may hold clues to an even older celestial event, one written not in sound but in starlight. Leaving behind the enigmatic hum of the skies, we now turn our gaze to a celestial spectacle etched into the memories of Australia's first peoples. The Vela Supernova, a cataclysmic explosion that lit up the heavens roughly 11,000 years ago, may have left its mark not just in the stars but in the ancient stories of Aboriginal cultures. Imagine a night sky suddenly split by a light so brilliant it cast shadows on the ground, a sight so unforgettable it became woven into oral traditions passed down through hundreds of generations. Among the Gunditjmara people of southeastern Australia, there are accounts of a great fire in the sky that brought both awe and foreboding. Some researchers suggest these stories could describe the Vela Supernova, one of the closest such events to Earth in recorded history. The remnants of this explosion, now known as the Vela Supernova remnant, still glow in the constellation Vela, a ghostly echo of that ancient blast. But here's where the mystery deepens. Modern astronomers have detected something unusual in this remnant, puzzling gamma-ray emissions that defy easy explanation. Some theories propose these rays come from a rapidly spinning neutron star, while others speculate about exotic particles or even dark matter interactions. What makes the Aboriginal connection so compelling is the precision of their celestial knowledge. Many indigenous stories align with specific astronomical events, from eclipses to meteor showers. For instance, the Boorong people of Victoria tell of an ancestor figure named Werpel, associated with the star Sirius, while the Wardaman people describe celestial beings in patterns that mirror modern constellations. Could the Vela supernova be another example of this sophisticated sky lore? The gamma-ray puzzle adds another layer. These high-energy emissions, invisible to the naked eye, were unknown to ancient cultures, yet their descriptions of the event's aftermath sometimes hint at strange, lingering effects. One oral tradition speaks of sickness in the air after the sky fire faded, a detail that eerily parallels modern understanding of radiation from cosmic events. As we piece together these fragments, oral histories, astronomical data, and the silent testimony of the stars, we're reminded that the cosmos speaks in more ways than one. Next, we'll uncover an artifact that blurs the line between myth and machine, the Baghdad Battery, a device that might have powered ancient stargazers' tools, or something far more mysterious. Now, shifting our focus from the celestial to the terrestrial, we encounter an artifact that blurs the line between ancient ingenuity and modern mystery, the Baghdad Battery. Discovered in the 1930s near the ruins of a 2,000-year-old Parthian village, this unassuming clay jar, roughly the size of a fist, contains a copper cylinder and an iron rod, all sealed with asphalt. At first glance, it might seem like nothing more than an ancient storage vessel, but when filled with an acidic liquid like vinegar or wine, it produces a small electric current. This startling discovery led some researchers to propose that it could have been an early form of battery, possibly used to power simple devices or even astronomical instruments. The idea that ancient civilizations might have harnessed electricity is tantalizing. Could the Baghdad Battery have been used to electroplate jewelry, as some suggest? Or perhaps it played a role in religious rituals, creating small shocks to all worshippers. But the most intriguing theory connects it to astronomy. Some speculate that paired with other devices, it might have powered early astrolabes or even primitive telescopes, aiding in celestial observations. Ancient texts from the region mention shining mirrors and glowing rods, descriptions that fuel speculation about lost technological knowledge, yet skepticism remains. Critics argue that the artifact lacks clear evidence of electrical use, no wires, no attached devices, and no contemporary descriptions of such technology. Instead, they propose it was simply a secure container for sacred scrolls, with the asphalt acting as a preservative seal. The iron and copper might have been incidental, or perhaps used for symbolic rather than functional purposes. What makes the Baghdad Battery so fascinating is the gap between what we know and what we imagine. If it was indeed a battery, it would rewrite our understanding of ancient innovation. But even if it wasn't, its very existence challenges us to reconsider the boundaries of ancient science. As we continue our journey through these astronomical enigmas, we'll next turn to a fiery visitor from the cosmos, the Greek fireball of 466 BC, a meteorite that left both physical and political scars on history. Now, let's turn our gaze to the skies of ancient Greece, where a blazing visitor from the cosmos left an indelible mark on history. In the year 466 BC, a fiery fireball streaked across the heavens before crashing near Aegospotami, a region known today for its connection to naval battles. Ancient writers like Plutarch and Pliny the Elder described it as a flaming beam or a torch in the sky, so bright it cast shadows even in daylight. The impact was so powerful that it reportedly shook the ground and left behind a smoldering crater, along with fragments of the meteorite itself, some of which were said to have been as large as wagons. What makes this event even more intriguing is how it became entangled with the politics of the time. The meteorite's arrival coincided with rising tensions between Athens and Sparta, and many saw it as an omen. Some interpreted it as a divine warning, while others claimed it signaled the favor of the gods. The philosopher Anaxagoras, known for his radical ideas about the cosmos, even suggested the fireball was a piece of the sun, a theory that reportedly landed him in trouble with Athenian authorities. The meteorite's fragments became objects of reverence, displayed in temples and studied by scholars, blending science and superstition in a way that defined the era. Today, the legacy of the Egyptian meteorite lives on. While the exact location of the impact remains debated, surviving accounts give us a vivid glimpse into how ancient civilizations processed celestial anomalies. Some fragments, like the one enshrined in the Temple of Zeus at Olympia, were lost to time, but others may still lie undiscovered, waiting to reveal more secrets about this dramatic encounter between Earth and the cosmos. As we piece together these ancient records, we're reminded that the sky has always been a canvas for both wonder and interpretation. Next, we'll explore how the Maya turned their eyes upward in a different way, using precise calculations to predict eclipses with astonishing accuracy. Now, shifting our focus from the fiery skies of ancient Greece to the precise celestial observations of the Maya, we uncover a different kind of astronomical mastery. The Maya civilization, renowned for their advanced understanding of the cosmos, left behind a treasure trove of knowledge in the Dresden Codex, one of the few surviving pre-Columbian books. Within its pages lie intricate eclipse tables that rival modern calculations in their accuracy, a testament to the Maya's extraordinary grasp of celestial cycles. These tables, meticulously recorded over centuries, predicted solar and lunar eclipses with remarkable precision. How did they achieve this without telescopes or modern technology? The answer lies in their relentless observation and sophisticated mathematics. By tracking the movements of the sun, moon, and planets across generations, Maya astronomers identified repeating patterns, such as the 585-day interval now known as the eclipse cycle. Their calculations were so refined that they could forecast eclipses decades in advance, often within a day or two of the actual event. But the Dresden Codex reveals more than just technical prowess. It offers a window into Mayan cosmology. Eclipses weren't merely celestial events to the Maya. They were omens tied to the divine and the fate of their rulers. The Codex depicts deities associated with eclipses, like the fearsome serpent Chak-Ek, symbolizing the moon's shadow swallowing the sun. These events were seen as battles between cosmic forces, moments when the balance of the world hung in the balance. Rituals, sacrifices, and prayers were conducted to appease the gods and ensure the sun's return. What's truly astonishing is how the Maya's eclipse predictions align with modern astronomy. Researchers have compared their tables to contemporary data and found startling accuracy, with deviations of mere hours over centuries. This level of precision suggests a deep, institutionalized tradition of observation, passed down through priest astronomers who dedicated their lives to decoding the heavens. As we marvel at the Dresden Codex, we're left with a profound appreciation for the Maya's intellectual legacy. Their ability to harmonize science, spirituality, and art in the study of eclipses reminds us that ancient astronomers were not just observers. They were storytellers, mathematicians, and philosophers of the cosmos. Next, we'll journey to Han Dynasty China, where another celestial anomaly, a mysterious guest star, captivated astronomers and reshaped our understanding of the universe. Leaving behind the eclipse tables of the Maya, we now turn our gaze to the skies of ancient China, where an extraordinary celestial visitor blazed into history. In the year 185, Han Dynasty astronomers recorded the sudden appearance of a brilliant guest star in the night sky, a mysterious light that lingered for months before fading away. What they witnessed was likely one of the most significant astronomical events in human history, a supernova so powerful it may have birthed the very concept of neutron stars. The Han records describe this guest star as appearing near the constellation we now call Centaurus, shining with an intensity that rivaled Mars, Unlike comets or meteors which move across the sky, this luminous object remained fixed, suggesting it was a distant stellar explosion. Modern astronomers have matched these ancient observations to the supernova remnant known as RCW86, a vast, expanding cloud of gas and dust roughly 8,000 light-years away. But here's where the story takes a fascinating turn. This supernova may hold the key to understanding one of the universe's most enigmatic objects. Decades of research suggest RCW86's unusual shape and extreme energy output align with the behavior of a neutron star, the ultra-dense core left behind after a massive star collapses. These cosmic powerhouses, first theorized in the 1930s, pack the mass of our Sun into a sphere no larger than a city. The Han Dynasty's guest star could represent one of the earliest documented sightings of a supernova giving birth to such an object, centuries before modern science grasped their existence. What makes this event even more remarkable is how meticulously Chinese astronomers documented it. Unlike many ancient cultures that viewed celestial anomalies purely as omens, Han scholars approached the guest star with a blend of reverence and scientific curiosity. Their records note its position, duration, and even changes in brightness details that have allowed modern researchers to reconstruct the supernova's timeline with surprising accuracy. Some historians argue this marks a pivotal moment in astronomy's evolution, where careful observation began to eclipse mythological explanations, yet the guest star's legacy extends beyond science. In Chinese cosmology, such phenomena were often interpreted as heavenly signs linked to earthly events. The supernova's appearance coincided with political turmoil in the Han Dynasty, leading some scholars to speculate whether it influenced court decisions or public sentiment. Whether as a celestial omen or a cosmic laboratory, this ancient light in the sky continues to illuminate our understanding of the universe's most violent and beautiful transformations. Next, we'll venture to the windswept plains of France, where the Karnak stones stand as silent witnesses to another ancient astronomical mystery. Now, let's journey from the celestial records of ancient China to the misty coastlines of Brittany, where the Karnak stones stand as one of Europe's most enigmatic astronomical puzzles. Stretching across nearly 4 kilometers, these thousands of weathered megaliths, some towering over 4 meters high, have baffled researchers for centuries. But what if their precise arrangement wasn't just ceremonial, but a sophisticated way to track the heavens? The most striking feature of the Karnak alignments is how rows of standing stones seem to frame key moments in the solar and lunar cycles. During the summer solstice, for instance, the sun rises directly over a specific menhir, casting shadows that align with neighboring stones like a giant celestial calendar. Even more intriguing, certain clusters appear to mark the moon's extreme positions during its 18.6-year cycle, known as the lunar standstill. This level of precision suggests Neolithic builders possessed a deep understanding of astronomy, one that allowed them to predict seasonal changes crucial for agriculture and rituals. Archaeoastronomers have proposed that the site functioned as a vast open-air observatory. One theory points to the Grand Menhir Brisset, a now-fallen giant that, when upright, may have served as a central sighting stone. From this vantage, observers could have used the alignments to anticipate eclipses or track planetary movements. Supporting this idea, some stones feature cup marks or carvings that could represent star patterns or counting systems. Yet skeptics argue that without written records, these interpretations remain speculative. Could the alignments be coincidental, or were they intentionally designed? What's undeniable is the scale of the builder's ambition. Erecting these megaliths between 4,500 and 3,000 BC required not just brute strength, but a shared cosmic vision. The stone's quartz-rich composition adds another layer of mystery. When struck or exposed to moonlight, they emit faint glows, possibly enhancing their ritual significance. Local legends speak of the alignments as a petrified Roman army, but modern science reveals a far older story written in stone and sky. As we ponder whether Karnak was an astronomical calculator, a sacred landscape, or both, its true purpose may lie somewhere between science and spirituality. Next, we'll unravel how another ancient culture, the Dogon people of Mali, claimed knowledge of stars invisible to the naked eye, sparking debates that stretch from anthropology to astrophysics. Shifting our gaze from the standing stones of Europe to the vast deserts of Mali, we encounter one of anthropology's most heated debates, the Dogon people's extraordinary knowledge of Sirius. This isolated tribe, with no access to modern telescopes, described Sirius not as a single star but as part of a binary system, accurately detailing the orbit of its invisible companion, Sirius B. How could a traditional African community know about a white dwarf star so dense it wasn't photographed until 1970? The Dogon's oral traditions, passed down through generations, speak of nomo-amphibious beings who descended from Sirius and shared cosmic secrets. Their astronomical lore includes precise details about Sirius B's 50-year elliptical orbit and its incredibly dense nature, facts Western science only confirmed in the 19th century. Some researchers, like ethnographer Marcel Grioul, argued this was evidence of advanced indigenous astronomy, while others proposed controversial theories of ancient extraterrestrial contact. Skeptics counter that the Dogon might have absorbed this knowledge from European visitors in the early 20th century, though tribal elders insist these stories predate colonial contact. Now, let's bridge this mystery with another enigma: the star maps of ancient Sumer. Clay tablets from Mesopotamia, dating back over 5,000 years, depict celestial configurations with startling accuracy, including references to planets like Neptune and Uranus, which shouldn't have been visible without telescopes. The most contentious claim revolves around the so-called 12th planet, Nibiru, described in cuneiform texts as crossing the inner solar system every 3,600 years. Mainstream archaeologists dismiss this as myth, but alternative historians ask, could the Sumerians have recorded astronomical phenomena now lost to time? What ties these two cultures together is their shared emphasis on Sirius. Sumerian cylinder seals showed deities flanking a star symbol often interpreted as Sirius, while their zodiac-like Emuel-a-pin tablets track its heliacal rising. Both civilizations, separated by continents and millennia, assigned Sirius profound spiritual significance, linking it to creation myths and divine knowledge. Whether this reflects independent discovery, forgotten cross-cultural exchange, or something more speculative remains fiercely debated. As we weigh these puzzles, one thing is clear: ancient skywatchers, whether in Mali or Mesopotamia, observed the heavens with a precision that still challenges our assumptions. Next, we'll turn to the American Southwest, where the Hopi people's blue star prophecy may hold clues to documented cosmic events. Now, let's journey from the ancient star maps of Sumer to the high deserts of the American Southwest, where the Hopi people have preserved a celestial prophecy that might just hold the key to real astronomical events. For generations, the Hopi have spoken of the blue star Kachina, a sign heralding the dawn of a new era. According to their oral traditions, the appearance of this brilliant blue star would signal profound changes for humanity. But here's the fascinating part: could this prophecy be linked to actual cosmic phenomena witnessed in the past? Some researchers suggest the blue star might correspond to historical supernova, those colossal stellar explosions that light up the night sky with extraordinary intensity. One compelling candidate is the supernova of 1054, which created the Crab Nebula and was recorded by Chinese astronomers as a star so bright it was visible even during the day. The Hopi's description of a radiant blue light matches the characteristics of certain supernova, which can emit vivid hues depending on their chemical composition. Could their ancestors have witnessed such an event and woven it into their cultural memory? Others propose the prophecy might reference rare planetary alignments or even comets with striking blue tails, like Hale-Bopp in 1997. The Hopis' intricate understanding of the cosmos, reflected in their ceremonial calendars and rock art, shows they were meticulous skywatchers. Their villages, like old Orebai, are aligned with solstice sunrises, proving their deep connection to celestial patterns. Whether the blue star symbolizes a specific event or a recurring astronomical sign remains open to interpretation, but the overlap between their traditions and documented cosmic occurrences is hard to ignore. What makes this prophecy especially intriguing is its timing. Hopi elders have long asserted that the blue star's arrival would precede a period of great transformation, a theme echoed in many ancient cultures facing celestial wonders. As we piece together these clues, we're left wondering, did the Hopi encode warnings or wisdom in their star lore that modern science is only beginning to decipher? Next, we'll unravel another artifact shrouded in mystery, the Phaistos disk, and ask whether its cryptic symbols might hold secrets of the stars. Turning our attention from the skies to the Earth, we encounter one of archaeology's most perplexing puzzles, the Phaistos disk. Discovered in 1908 on the Greek island of Crete, this fired clay disk, roughly the size of a small plate, is covered in spiraling symbols stamped on both sides. At first glance, it might seem like an ancient work of art, but the mystery lies in its purpose. Could these cryptic symbols be more than decoration? Some researchers believe the disk might hold astronomical secrets, a coded message from the Minoan civilization that thrived over 3,000 years ago. The symbols themselves are unlike any other writing system from the era. From human figures and animals to abstract shapes resembling tools or celestial objects, the imagery has fueled endless speculation. One compelling theory suggests the symbols could represent a lunar calendar, tracking the phases of the moon for agricultural or ritual purposes. The spiral pattern, winding inward, might even mirror the cyclical nature of celestial events like eclipses or planetary movements. But without a clear key to decode the symbols, the disk remains a tantalizing enigma. Another angle points to the disk's potential as an early astronomical instrument. Some symbols bear a striking resemblance to star clusters or constellations, leading to theories that the Minoans used it to predict seasonal changes or navigate the seas. The advanced maritime culture of Crete would have relied heavily on the stars, making such a tool invaluable. Yet, skeptics argue the symbols could simply be religious or ceremonial, with no connection to the cosmos at all. What makes the Phaistos disk so fascinating is its isolation. No other artifact like it has ever been found. If it does encode astronomical data, it would push back our understanding of ancient scientific knowledge by centuries. But until someone cracks its code, the disk stands as a silent witness to a lost world's ingenuity. As we continue our journey through these ancient mysteries, we'll next examine a Roman omen that shook an empire, the eerie phenomenon of two suns appearing in the sky. Now, let's step into the world of ancient Rome, where the skies themselves seem to conspire in the drama of history. Just weeks before the assassination of Julius Caesar in 44 BC, a bizarre celestial event was recorded by the historian Plutarch, a second sun appearing in the sky. Witnesses described it as a glowing orb mirroring the real sun, an omen so unsettling it sent ripples of fear through the empire. Plutarch's account paints a vivid picture. The twin suns were said to hover side by side, casting eerie double shadows. To the superstitious Romans, this was no mere atmospheric quirk. It was a divine warning, a sign of upheaval and betrayal. And just days later, Caesar was stabbed to death in the Senate, a turning point that would plunge Rome into civil war. But what could have caused such a spectacle? Modern astronomers have proposed several explanations. One leading theory points to a rare atmospheric phenomenon called a parhelion, or sun dog. These occur when sunlight refracts through ice crystals high in the atmosphere, creating bright spots that mimic additional suns. Under the right conditions, the effect can be startlingly realistic. Another possibility is an unusually bright meteor or comet fragment burning up in the atmosphere, though these events are typically fleeting. Yet the timing of the two suns' omen remains uncanny. Whether a natural occurrence or a trick of the light, its psychological impact was undeniable. In a society where celestial signs were taken as messages from the gods, the event became forever tied to Caesar's downfall. Some even speculate that the omen was embellished after the fact, a dramatic flourish to underscore the gravity of his murder. As we peel back the layers of this ancient mystery, it's a reminder of how the heavens and human history are often intertwined. Next, we'll journey to the American Southwest, where a puebloan carving known as the Sun Dagger reveals an equally fascinating connection between the sky and the earth. Leaving the intrigue of Rome behind, we now travel to the arid landscapes of the American Southwest, where an ancient puebloan masterpiece silently tracks the passage of time. High atop Fajada Butte in New Mexico's Choco Canyon, a set of spiral petroglyphs known as the Sun Dagger transforms sunlight into a celestial calendar. Carved over 1,000 years ago, this ingenious rock art doesn't just decorate the cliffs, it speaks the language of the cosmos. Here's how it works. During the summer solstice, a slender beam of sunlight pierces through a carefully positioned slab of rock, slicing directly through the center of the largest spiral. At the winter solstice, two dagger-like shafts of light perfectly bracket the same spiral. Even the equinoxes are marked with a single beam bisecting a smaller spiral nearby. These aren't accidents. The precision required to align the carvings with the sun's shifting angles reveals an advanced understanding of astronomy. Archaeologists believe the Sun Dagger served as more than a calendar. For the ancestral Puebloans, it likely held spiritual significance, tying their rituals to the rhythms of the sky. The solstices marked critical moments for agriculture, signaling when to plant or harvest crops in the unforgiving desert. But the site's remote location, perched high on a butte, suggests it may have also been a sacred space, accessible only to spiritual leaders or astronomers. Modern researchers faced their own mystery when studying the Sun Dagger. In the late 20th century, they noticed the alignment had shifted. Erosion and human interference, including the installation of measurement equipment, had altered the delicate balance of the slabs. Today, the original effect is no longer perfectly visible, a reminder of how fragile these ancient wonders can be. What's astonishing is how the Puebloans achieved such accuracy without written records or modern tools. Some scholars speculate they used wooden pegs or shadows to map the sun's path over years of observation. Others suggest the knowledge was passed down through generations, refined by countless watchers of the sky. The Sun Dagger stands as proof that astronomy isn't just the domain of high-tech observatories. Long before telescopes, humans found ways to read the heavens etched in stone. Next, we'll uncover how fragments of a Greek astronomer's lost star catalogue might have survived in the unlikeliest of places. Turning our gaze from the sunlit cliffs of Choco Canyon, we journey back to the ancient Mediterranean, where one of history's greatest astronomical puzzles lies hidden in plain sight. The lost star catalogue of Hipparchus, a Greek astronomer who mapped the heavens over 2,000 years ago, was long thought to vanish with the collapse of classical civilization. But recent discoveries suggest fragments of his groundbreaking work may have survived tucked away in the pages of medieval manuscripts. Hipparchus, often called the father of scientific astronomy, compiled the first comprehensive star catalogue around 134 BCE. His work recorded the positions and brightness of over 850 stars, a feat that wouldn't be matched for centuries. Using simple instruments like the astrolabe, he even detected the slow wobble of Earth's axis, a phenomenon we now call precession. But after the Library of Alexandria burned, his original writings were lost to time, or so we believed. The breakthrough came when scholars scrutinizing a 9th century Christian manuscript noticed something unusual. Beneath the Latin text, faint traces of Greek writing hinted at an older, erased document. Using multispectral imaging, researchers uncovered astronomical coordinates matching stars in the constellation Corona Borealis. The precision of these measurements pointed to one source, Hipparchus. It's as if his ghostly hand had reached across centuries, leaving clues in the parchment. Why would medieval scribes overwrite such valuable knowledge? The answer lies in the scarcity of materials. Parchment was expensive, and older texts were often scraped clean to make room for new ones. Ironically, this practice, called palimpsesting, may have preserved Hipparchus's data by hiding it beneath layers of ink. Other fragments have since surfaced in monasteries across Europe, each a tiny piece of his celestial puzzle. What makes these discoveries so thrilling is how they challenge our assumptions. For years, historians credited later astronomers like Ptolemy with advancing star mapping. But the recovered fragments suggest Ptolemy may have built directly on Hipparchus's work, perhaps even copying parts of his catalogue. This reshapes our understanding of how astronomical knowledge was transmitted and lost across the ages. The hunt for Hipparchus's legacy isn't over. Researchers now scour archives with advanced imaging tools, hoping to reveal more hidden stars. Each recovered coordinate is a testament to human curiosity, a thread connecting modern science to an observer who once gazed at the same night sky. Next, we'll venture to the Andes, where an Incan observatory carved into the mountains reveals another chapter in humanity's celestial story. High in the Andes, where the air thins and the sky feels close enough to touch, the ruins of Huayra Pucará hold secrets carved not just in stone but in sunlight itself. This remote Peruvian site, whose name means horn-shaped fortress in Quechua, was long thought to be a military outpost until researchers noticed something extraordinary. Its towering rock formations act like a colossal calendar, marking the equinoxes with razor-sharp precision. On the mornings of the spring and autumn equinox, when day and night hang in perfect balance, sunlight pierces a narrow gap between two massive stone horns. The beam strikes a precisely carved niche in the central plaza, illuminating symbols linked to Inca cosmology. This wasn't just architecture, it was a celestial observatory designed to harmonize with the rhythms of the cosmos. What makes Huayra Pucará unique is how it blends astronomy with sacred geography. The Incas saw mountains as living deities, and this site aligns not only with solar events but with distant peaks on the horizon. During the winter solstice, the rising sun appears to crown the summit of Orsungate, a glacier-capped mountain revered as an Apu or mountain spirit. Such alignments suggest the Incas mapped the sky onto the land, turning the entire landscape into a cosmic diagram. Archaeologists have uncovered more clues in the surrounding structures. A series of trapezoidal windows, a hallmark of Inca design, frame specific stars in the Pleiades cluster critical for agricultural timing in the high Andes. Nearby, a stone altar bears grooves that may have held offerings to Inti, the sun god, during key astronomical events. Even the site's isolation speaks volumes. Perched at nearly 14,000 feet, Huayra Pucará offered an unobstructed view of the heavens, far from the light pollution of cities. The sophistication of this observatory challenges old stereotypes about pre-Columbian science. Unlike Western telescopes, which separate observer from sky, Huayra Pucará's design immerses you in the celestial dance. To stand there at dawn on an equinox is to feel the Inca worldview firsthand, a universe where astronomy, religion, and daily life were inseparable. Yet mysteries remain. Who precisely designed these alignments? How did they achieve such accuracy without written records? Some scholars speculate that Huayra Pucará may encode knowledge even older than the Incas, inherited from cultures like the Wari. As we continue our journey through ancient astronomical wonders, we'll next encounter a celestial event so dramatic it shook the ancient world, the Greek comet of 373 BCE, a fiery omen tied to earthquakes and empire. Now, let's turn our gaze to ancient Greece, where the skies delivered a spectacle that left historians and astronomers puzzled for centuries. In the year 373 BC, witnesses reported a terrifying sight, a blazing streak of light tearing across the heavens described as a fiery beam in ancient texts. Some accounts claimed it lingered long enough to cast shadows at noon, while others swore it heralded disaster, and disaster did follow. Just days later, the coastal city of Helike was swallowed by the sea in a catastrophic earthquake, leading many to believe the celestial event was a divine warning. But what exactly did the Greeks see? Modern scholars debate three possibilities. The first theory suggests it was a brilliant meteor, perhaps a fireball so large it fragmented in the atmosphere, creating an otherworldly glow. Meteors were often interpreted as omens in antiquity, and this one's timing right before Helike's destruction would have cemented its reputation as a portent. The second theory points to an aurora, a rare but not impossible sight in Mediterranean latitudes. Ancient descriptions of dancing lights could align with auroral activity, though the connection to the earthquake remains unexplained. The most intriguing theory ties the event to a geological phenomenon. Some researchers propose that the fiery beam was actually earthquake lightning, a luminous discharge caused by tectonic stress. If true, it would mean the Greeks witnessed a rare precursor to the quake itself, a natural early warning system they couldn't comprehend. Supporting this, excavations at Helike have revealed evidence of sudden subsidence, as if the city sank into a watery grave overnight. The Helike disaster reshaped Greek politics and religion. Survivors interpreted the event as punishment from Poseidon, god of the sea, and his cult grew rapidly in the aftermath. Meanwhile, philosophers like Aristotle later cited the comet and earthquake as proof that celestial and earthly events were intertwined, an idea that would influence scientific thought for millennia. Yet the mystery endures. No surviving records pinpoint the exact date or trajectory of the comet, leaving room for doubt. Could it have been a supernova misplaced in time by later chroniclers, or perhaps an atmospheric anomaly lost to history? What's certain is that this event blurred the line between astronomy and geology, reminding us that the ancients observed the skies with a mix of awe and apprehension we've never quite outgrown. Next, we'll uncover another artifact where the heavens meet human hands, the Nebra Sky Disk, a Bronze Age enigma that might just be the world's oldest portable star map. Now, let's journey from the fiery skies of ancient Greece to the quiet forests of modern-day Germany, where a discovery in the late 1990s rewrote our understanding of Bronze Age astronomy. The Nebra Sky Disk, a stunning bronze artifact inlaid with gold, is often called the oldest known depiction of the cosmos, but what exactly does it show? Unearthed by treasure hunters near the town of Nebra, this disk, roughly the size of a dinner plate, immediately sparked debate. Its gold symbols, a cluster of stars, a crescent moon, and what appears to be a sun or full moon, suggest it wasn't just decorative. Some researchers argue the star cluster represents the Pleiades, a group of stars prominently featured in myths across Europe and the Near East. For ancient farmers, the Pleiades' position in the sky marked planting and harvest seasons, making this disk a possible agricultural calendar. Others see a deeper celestial story. The large golden arc on the disk's edge has been interpreted as a solar barge, a mythological vessel believed to carry the sun across the sky in Egyptian and Nordic traditions. If correct, the disk might blend astronomical observation with spiritual beliefs, showing how early cultures connected the heavens to their daily lives. But the most tantalizing theory comes from a pair of smaller arcs added later to the disk's sides. When aligned with specific landmarks in the Nebra region, these arcs could track the solstices, turning the disk into a portable observatory. Even more striking, some scholars propose the entire design predicts eclipses. By tracking the moon's position relative to the Pleiades, Bronze Age skywatchers might have anticipated lunar eclipses, a feat requiring advanced knowledge of celestial cycles. Not everyone agrees, of course. Critics point out that the disk's symbols could be purely symbolic, with no practical astronomical use. The fact that it was buried with swords and axes suggests it might have been a ceremonial object, perhaps used in rituals rather than stargazing. What's undeniable is the Nebra sky disk's craftsmanship. The precision of its gold inlays reveals a society far more sophisticated than we once assumed, capable of merging art, science, and spirituality into a single object. Whether it's a star map, a religious icon, or an eclipse calculator, this disk proves our ancestors looked up at the same skies we do and saw not just stars but stories, warnings, and wisdom written in the light. Next, we'll step into the shadow of towering stones, where ancient builders aligned massive monuments with the winter sun's first rays. The Karnak alignments and Newgrange passage tomb hold secrets of a time when architecture itself worshipped the heavens. Shifting our gaze from the Nebra sky disk's portable cosmos to the monumental landscapes of ancient Europe, we arrive at two breathtaking sites where stone and sky collide: the Karnak alignments in France and Newgrange passage tomb in Ireland. These awe-inspiring structures, built thousands of years apart, share a sacred connection. Both were meticulously designed to capture the magic of the winter solstice, turning architecture into a celestial theater. First, let's wander among the Karnak alignments, where over 3,000 standing stones stretch across the Breton countryside like a petrified army. Arranged in parallel rows spanning miles, these megaliths have puzzled archaeologists for centuries, but one clue to their purpose lies in their alignment. During the winter solstice, the shortest day of the year, the rising sun casts long shadows that seem to animate the stones, creating a dramatic interplay of light and shadow. Some researchers believe this spectacle was more than just a calendar. It may have symbolized a rebirth ritual, as the returning sun promised the earth's renewal. Local legends even speak of the stones as pagan soldiers turned to stone by Christian saints, a poetic nod to the site's enduring spiritual aura. Now, cross the sea to Ireland's Newgrange, a massive passage tomb older than Stonehenge and the pyramids. Its most astonishing feature, a narrow roof box above the entrance, perfectly positioned to funnel a beam of sunlight deep into the inner chamber, but only at dawn on the winter solstice. For roughly 17 minutes, the chamber floods with golden light, illuminating ancient spiral carvings that may represent the sun's cyclical journey. This wasn't just an engineering marvel, it was a profound spiritual event. Imagine ancient gatherers huddled inside, witnessing this celestial miracle, a moment when the boundary between the living and the ancestors seemed to thin, as if the sun itself were a messenger from the other side. What ties these sites together isn't just their solstice magic, but their hints of a shared astronomical language. Both Karnak and Newgrange show how Neolithic cultures, separated by time and distance, sought to harness the sun's power in stone. Were they honoring gods, tracking time, or communing with the dead? The stones won't say, but their silent alignment with the heavens whispers that for our ancestors, the winter solstice wasn't just a date, it was a divine encounter. Up next, we'll unravel an Egyptian enigma hidden in pyramid texts, a star so elusive, modern astronomers still debate its identity. The mystery of the unseen star reveals how ancient skywatchers recorded celestial secrets we're only beginning to decode. Now, let's journey from the solstice-aligned stones of Europe to the sands of ancient Egypt, where pyramid texts hold clues to a celestial mystery that still baffles astronomers today: the so-called unseen star. Deep within the sacred inscriptions of the pyramids, there are cryptic references to a star that, according to the ancients, was hidden from human sight yet played a pivotal role in their cosmology. The most compelling theory links this enigmatic star to Sirius A, the brightest star in our night sky. Ancient Egyptian texts describe Sirius as having a companion, one that was invisible to the naked eye. Modern astronomy confirms that Sirius does indeed have a faint white dwarf companion, Sirius B, which wasn't officially discovered until the 19th century. So how did the Egyptians know about it thousands of years earlier? Some scholars suggest their advanced knowledge came from meticulous observation over generations, noting subtle gravitational effects or irregularities in Sirius's movement. Others propose that this unseen star was part of their spiritual cosmology, symbolizing the hidden realm of the gods or the afterlife. The pyramid texts often associate this mysterious star with the goddess Sopdet, the personification of Sirius, and her role in the Nile's annual flooding. The rising of Sirius just before dawn, known as the Heliacal Rising, marked the beginning of the inundation, a life-giving event for Egyptian agriculture. If the unseen star was indeed Sirius B, its inclusion in their texts might reflect a deeper understanding of celestial mechanics, or perhaps a symbolic duality, the seen and unseen forces governing their world. Yet not all researchers agree. Some argue the unseen star could represent a different celestial phenomenon, like a now-faded supernova or a planet obscured by dust clouds. The debate continues, but what's undeniable is the Egyptians' sophisticated grasp of the night sky. Their ability to weave astronomical observations into mythology and ritual reveals a culture that saw the cosmos as both a scientific map and a divine narrative. As we piece together these ancient puzzles, one thing becomes clear: the Egyptians weren't just stargazers. They were cosmic storytellers, encoding secrets in stone that we're still deciphering. Next, we'll turn to Mesopotamia, where clay tablets known as the Emuel, a pin catalogued the stars with astonishing precision, laying the groundwork for the zodiac we know today. Leaving the celestial mysteries of Egypt behind, we now travel to the heart of ancient Mesopotamia, where a remarkable clay tablet known as the Emuel, a pin, offers us a window into the world's earliest systematic astronomy. This Babylonian artifact, dating back to around 1000 BC, isn't just a list of stars, it's a sophisticated guide to the heavens, blending science, mythology, and practical timekeeping in ways that still resonate today. The name Emuel, a pin, translates to the plough star, a reference to the constellation we now call Triangulum, but this tablet goes far beyond a single star. It meticulously catalogues over 60 stars and constellations, mapping their movements across the sky throughout the year. What's astonishing is how it divides the sky into 3 distinct paths: the paths of Enlil, Anu, and Ig, corresponding to northern, equatorial, and southern celestial regions. This 3-tiered system reveals a level of observational precision that wouldn't be matched for centuries. Beyond mere stargazing, the mole, a pin, served as an agricultural and ritual calendar. It pinpointed the heliacal risings of key stars, signaling when to plant crops or hold religious festivals. For example, the rising of the Pleiades marked the start of the Babylonian New Year, while Sirius's appearance warned of impending floods. This wasn't just astronomy, it was a survival manual etched in clay. Perhaps most intriguing are the tablet's planetary observations. It tracks Venus, Jupiter, and other wandering stars, noting their cyclical patterns with surprising accuracy. Some scholars argue these records laid the groundwork for the zodiac centuries before the Greeks formalized it. Others see hints of mathematical astronomy, with the Babylonians calculating planetary positions using early forms of arithmetic progression. Yet the Emuel, a pin, isn't purely scientific. Like the Egyptians, the Babylonians wove myth into their cosmos. The tablet associates stars with gods, Ishtar as Venus, Marduk as Jupiter, blending celestial mechanics with divine intervention. This duality captures the essence of Mesopotamian thought. The sky was both a clock and a sacred text. As we decipher these ancient tablets, we're left with a profound realization. The Babylonians didn't just watch the stars, they systematized them, creating a legacy that would shape Greek, Indian, and Islamic astronomy. Next, we'll see how Chinese astronomers turned their gaze to another celestial marvel: the broom stars that swept across their skies, heralding both wonder and warning. Turning our gaze eastward, we arrive in ancient China, where celestial phenomena weren't just observed, they were meticulously recorded as cosmic messages. Among these, the so-called broom stars held a special place in the imperial courts. These weren't ordinary stars but comets, their sweeping tails resembling celestial brooms sweeping across the night sky. To the Chinese, they were anything but random. They were omens often tied to the rise and fall of dynasties. The earliest surviving records date back to the Shang dynasty, around 1600 BC, where oracle bones mention guest stars with long tails. By the Han dynasty, these observations became systematic. The Book of Han, compiled in the 1st century AD, details over 30 comet sightings, complete with notes on their color, direction, and even the sound of their movement, a testament to the precision of Chinese astronomers. Halley's Comet takes center stage in these chronicles. Its appearance in 240 BC was documented as a broom star that pointed northeast, interpreted as a warning to the Qin dynasty. When it returned in 87 BC, scribes noted its baleful glow, coinciding with political upheavals, but the most famous record comes from 1666, when its appearance was linked to the death of a Ming emperor and the subsequent rise of the Qing dynasty. What's fascinating is how these interpretations were codified. The Mawangdui silk texts buried in a tomb around 168 BC include detailed illustrations of 29 comet types, each tied to specific omens. A forked tail meant famine, a straight tail signaled war. Even the comet's path held meaning. Crossing the Milky Way was seen as a direct challenge to the celestial order. Yet behind the superstition lay cutting-edge science. Chinese astronomers were among the first to realize comets were atmospheric phenomena, not divine interventions. By the Tang dynasty, they'd calculated Halley's orbit with remarkable accuracy, centuries before Europe's Edmund Halley. These records reveal a duality, comets as both scientific curiosities and political tools. Emperors used them to justify reforms or purge rivals, while astronomers quietly refined their predictions. It's a reminder that in ancient China, the sky wasn't just watched, it was read like a scroll of power and prophecy. Next, we'll encounter a celestial tale from Greek mythology that might hide a real astronomical disaster: the fiery fall of Phaethon. Now, let's journey from the meticulous records of ancient China to the vivid storytelling of Greek mythology, where celestial drama took on a deeply human form. The myth of Phaethon, the reckless son of the sun god Helios, reads like a cosmic cautionary tale. But could it also hide a real astronomical event? According to the legend, Phaethon begged his father to let him drive the sun chariot across the sky for a single day. But losing control, he scorched the earth, creating deserts in Africa and darkening the skin of its people, before Zeus struck him down with a thunderbolt to prevent total catastrophe. At first glance, it's a story about hubris, yet scholars have long wondered if this myth preserves the memory of an actual celestial disaster. One compelling theory suggests Phaethon's fall mirrors a massive meteorite impact. Ancient writers like Pliny the Elder and Seneca described a star that crashed near the Eridanus River, a location later linked to the myth. Geological evidence from around 1200 BC shows a period of abrupt climate cooling in the Mediterranean, possibly caused by debris from a fragmented comet. Could this have inspired the tale of a sky chariot gone awry? Alternatively, some researchers propose the myth encodes a violent solar storm. The description of the sun wandering and the earth burning aligns with accounts of auroras so intense they mimic daylight, a rare but documented phenomenon. Greek texts mention blood-red skies and fiery rain during Phaethon's ride, eerily similar to the effects of a coronal mass ejection hitting Earth's atmosphere. What makes this myth especially intriguing is its persistence. Versions appear in Ovid's Metamorphoses, Euripides' Lost Play Phaethon, and even Etruscan art. Each retelling adds layers, from Phaethon's grieving sisters turning into amber weeping poplar trees to the river Eridanus symbolizing the Milky Way. This wasn't just a story, it was a cultural touchstone, possibly rooted in collective memory of a real sky-borne catastrophe. Whether meteorite, solar storm, or pure allegory, Phaethon's tale reminds us that ancient myths often served as vessels for astronomical observation. Next, we'll cross the globe to Australia, where the Aboriginal emu in the sky reveals an entirely different way of mapping the cosmos, not with chariots, but with dark constellations. Leaving behind the fiery drama of Greek mythology, we now turn to a celestial story told not with bright stars, but with the spaces between them. The Aboriginal emu in the sky reveals how ancient cultures saw the night sky in ways modern astronomy often overlooks. Unlike Western constellations that connect stars into shapes, Aboriginal Australians mapped the cosmos using dark patches of the Milky Way. The emu in the sky is one of the most striking examples, a sprawling figure formed by the Crab Nebula near the Southern Cross. When viewed from Earth, this dense cloud of interstellar dust blocks starlight, creating the silhouette of a running emu. Its posture changes with the seasons, lying horizontally during autumn evenings as if sitting on eggs, then stretching vertically in spring as if standing to run. This wasn't just artistic imagination. The emu's seasonal shifts aligned with practical knowledge. When the emu appeared to sit, it signaled the start of egg-gathering season, a crucial food source. Some rock engravings, like those in Ku Ring Guide Chase, mirror the emu's celestial position, suggesting these dark constellations were part of an oral and visual teaching system. The Crab Nebula itself adds another layer of mystery. Modern telescopes reveal it's a stellar nursery birthing new stars, something Aboriginal elders may have intuited through generations of observation. In some traditions, the emu's movement also marked initiation ceremonies or warned of taboo periods when certain foods shouldn't be harvested. What makes this tradition extraordinary is its longevity. While Greek and Babylonian star maps were recorded on clay tablets, Aboriginal astronomy was preserved through songlines, oral narratives mapping the land and sky together. Recent studies show these traditions may date back over 65,000 years, making them arguably the oldest continuous astronomical knowledge on Earth. From a scientific perspective, the emu in the sky challenges how we define constellations. Most cultures focused on bright stars, but Aboriginal astronomers treated the Milky Way's dark lanes as equally meaningful. It's a reminder that the night sky holds countless stories depending on who's looking and how. As we move forward, prepare to encounter another ancient navigational tool, one that helped Vikings sail treacherous northern seas. The Viking sunstone awaits, where myth and practicality collide in the glitter of calcite crystals. Now, let's journey from the star maps of Aboriginal Australia to the foggy seas of the North Atlantic, where Viking sailors faced a different kind of celestial challenge. Imagine navigating open waters under a sky choked with clouds, the sun hidden for days, yet somehow the Norse still found their way. The secret may lie in a seemingly ordinary crystal, the Viking sunstone. Ancient texts like the Rotholf's Thota describe a mysterious solar stone that could reveal the sun's position even when obscured by clouds or fog. Modern researchers believe this could refer to calcite crystals, a type of mineral that polarizes light. When held up to the sky, calcite splits sunlight into two beams, creating a visual effect called double refraction. By rotating the crystal until the beams match in brightness, navigators could pinpoint the sun's location with surprising accuracy. But did Vikings truly use this method? Experimental archaeologists put it to the test. In one study, a team sailed a reconstructed Viking ship using only a calcite crystal on overcast days and successfully stayed on course. The crystal's margin of error was less than 1 degree, rivaling modern compasses. Even more intriguing, a calcite fragment was found aboard a 16th century English shipwreck, hinting that the technique may have outlasted the Viking Age. Skeptics argue that no sunstones have been found in Viking graves or settlements, But absence of evidence isn't evidence of absence. Norse sagas brim with practical navigation tips, from reading wave patterns to tracking migratory birds. The sunstone fits this ingenuity, a tool born of necessity in a world where fog could mean death. What's fascinating is how this blends myth and science. Viking lore often depicted the sun as a chaste goddess or a wheel of fire, yet their navigators likely relied on raw physics. Calcite's properties aren't magic, they're a quirk of nature the Norse observed and exploited. It's a reminder that ancient technology wasn't primitive, just different. As we leave the Vikings' glittering sunstones behind, our next stop takes us to the highlands of Mesoamerica, where the Toltecs carved enigmatic figures adorned with celestial symbols. Were these mere decorations or evidence of something far stranger? Shifting our gaze from the misty seas of the north to the sun-baked plains of ancient Mexico, we arrive at the ruins of Chala, once the heart of the Toltec civilization. Here, towering stone figures known as the Atlantean warriors stand guard, their bodies adorned with intricate carvings that have sparked centuries of debate. Among these enigmatic designs are symbols resembling stars, celestial bodies, and what some believe to be representations of otherworldly visitors, the so-called Toltec star beings. The most striking of these carvings can be found on the pillars of Chala's temple of Tlahuizcalpantecutli, dedicated to the morning star or Venus. Etched into the stone are humanoid figures wearing elaborate headdresses, their eyes wide and their poses rigid as if frozen in mid-ritual. Surrounding them are swirling patterns that some researchers interpret as stylized comets or constellations, while others see them as abstract depictions of energy or even advanced technology. One theory suggests these figures represent the Toltecs' reverence for celestial deities, blending astronomy with mythology. The Toltecs, like many Mesoamerican cultures, tracked Venus with precision, and their carvings might symbolize the planet's cyclical appearances. But another, more controversial idea posits that the star beings are evidence of ancient encounters with extraterrestrial beings. Proponents of this view point to the figures' elongated heads and what appear to be helmets or breathing apparatuses, arguing they resemble modern depictions of astronauts. Mainstream archaeologists, however, caution against jumping to otherworldly conclusions. They note that the Toltecs were masterful artists who often used symbolism to convey spiritual concepts. The helmets could represent ceremonial masks, and the star maps might simply be decorative motifs tied to their cosmology. Yet, even skeptics admit the carvings are unusual, unlike anything found in neighboring cultures like the Maya or Aztecs. Adding to the intrigue, Toltec legends speak of Quetzalcoatl, the feathered serpent god, who descended from the heavens with knowledge of astronomy and agriculture. Could this myth be a cultural memory of contact with an advanced civilization or even visitors from beyond Earth? The truth remains buried in the stones of Chala, waiting for fresh interpretations. As we ponder these mysteries, our journey takes us next to the battlefields of ancient Sicily, where Carthaginian soldiers witnessed a celestial event so terrifying it was said to rain fire from the sky. Now, let's turn our attention to a moment when the skies themselves seemed to wage war alongside mortals. During the siege of Syracuse in 214 BC, Carthaginian soldiers and Greek defenders alike witnessed a phenomenon so terrifying it was etched into history as the fire rain. Ancient accounts describe a night when the heavens appeared to fracture, unleashing a storm of flaming debris upon the battlefield. Historians believe this event was likely a spectacular meteor shower, perhaps the remnants of a comet or asteroid breaking apart in Earth's atmosphere. The psychological impact on the troops was immediate and profound. To soldiers already locked in a brutal conflict, the sudden barrage of fire from above felt like divine intervention or punishment. The Carthaginians, known for their superstitious nature, interpreted it as an ominous sign, while the Syracusans saw it as a portent of their eventual victory. One surviving record, attributed to the Greek historian Polybius, claims the meteor shower caused such panic that entire units broke formation, fearing the gods had turned against them. The Carthaginian general Hannibal's ally Hamilcar reportedly ordered sacrifices to appease the heavens, but the damage to morale was irreversible. Some scholars argue this celestial spectacle may have even influenced the siege outcome, as the shaken Carthaginians grew increasingly hesitant in their assaults. Modern astronomers have traced potential candidates for this event, including the debris trail of Comet Halley, which passed near Earth around that time. Yet, what makes the fire rain so compelling isn't just the science behind it, it's the way ancient minds processed the unexplainable. For them, the sky wasn't just a backdrop, it was an active participant in human affairs, capable of bending the fate of empires with a single, fiery display. As we reflect on how celestial events shaped ancient warfare, our next stop takes us to the quiet forests of medieval Europe, where a peculiar calendar carved into bronze may hold secrets to predicting eclipses. Shifting our gaze from the battlefields of Syracuse to the ancient courts of China, we uncover a civilization that turned the heavens into a language of power and prophecy. Among the most fascinating relics of the Shang dynasty, which thrived over 3,000 years ago, are the oracle bones pieces of ox scapulae or turtle plastrons used for divination. But these weren't just tools for fortune-telling. Scratched into their surfaces are some of humanity's earliest records of eclipses, revealing a sophistication in celestial observation that would rival modern astronomy. The Shang rulers believed the cosmos communicated through omens, and eclipses were among the most potent. When the sun or moon vanished unexpectedly, scribes would inscribe the event on oracle bones, often alongside questions like, "Will the king avoid disaster?" Or, "Is this a sign of the ancestors' displeasure?" One bone from around 1200 BC famously records a solar eclipse so precise that modern astronomers have matched it to an actual event on June 5th of that year. The inscription reads, "The sun was eaten," reflecting the ancient Chinese belief that a celestial dragon devoured the light. What's even more remarkable is how these records demonstrate predictive ability. By the late Shang period, court astronomers had begun noticing patterns like the 18-year Saros cycle, which predicts eclipse repetition. This wasn't just myth-making, it was proto-science. The bones even show practice inscriptions, where scribes rehearsed eclipse calculations before engraving them, proving a systematic study of the skies. Pairing these artifacts with later Shang eclipse records paints a picture of a bureaucracy obsessed with celestial order. Eclipses weren't merely feared, they were meticulously tracked, their occurrences used to legitimize rulers or warn of crop failures. When a king's diviners accurately predicted an eclipse, it reinforced his divine mandate. When they failed, it could spark unrest. This blend of astronomy and statecraft reveals how the Shang didn't just watch the skies, they weaponized their knowledge, turning cosmic phenomena into tools of control. And as we'll soon see, this interplay of power and the heavens wasn't unique to China. Just wait until we explore how the Incas used their own celestial observations to build an empire under the stars. Now let's turn our attention to the skies over ancient Greece, where stargazers grappled with a celestial puzzle that defied explanation for centuries: the mysterious behavior of the so-called wandering stars. Unlike the fixed patterns of constellations, these bright points of light seem to move independently, sometimes even reversing course against the backdrop of the night sky. Among them, Mercury was the most elusive, darting so close to the sun that it often vanished from view for months at a time. To the Greeks, this erratic motion was baffling. Philosophers like Aristotle argued that the heavens were perfect and unchanging, yet here were stars that refused to follow the rules. Early attempts to explain their paths were steeped in mythology. Some imagined the wanderers as celestial chariots driven by gods, while others, like Plato, suggested they moved in divine, perfect circles. but observations kept contradicting these ideas, especially when planets like Mars appeared to loop backward in retrograde motion. The breakthrough came with Claudius Ptolemy in the 2nd century. His geocentric model, though later proven incorrect, finally offered a working explanation. By introducing complex circles upon circles epicycles, Ptolemy mathematically accounted for the planet's strange dances. Mercury's path, for instance, was traced as a series of tight loops around an imaginary point, reconciling its erratic appearances with the Greek belief in celestial harmony. What's fascinating is how long this model endured. Even with its flaws, Ptolemy's system became the backbone of astronomy for over 1,000 years, proving that sometimes a flawed answer is better than no answer at all. And it all started with those wandering stars, celestial rebels that challenged humanity to think deeper about the cosmos. Next, we'll see how another civilization, high in the Andes, interpreted a darkened sun not as a puzzle to solve, but as a divine omen with earth-shaking consequences. Now, let's journey to the towering peaks of the Andes, where the Inca civilization witnessed a celestial event so unsettling it became etched into their collective memory, the ominous black sun. Imagine the terror of watching the life-giving sun dim inexplicably, as if swallowed by an unseen force. For the Inca, whose entire cosmology revolved around solar worship, this wasn't just an astronomical anomaly, it was a divine message demanding interpretation. Their oral traditions speak of Inti, the sun god, temporarily withdrawing his light, plunging the world into an eerie twilight. Some accounts describe the sun appearing sick or dirty, its usual brilliance muted by a strange, ashy veil. Modern researchers now speculate, was this a volcanic eruption's aftermath, like the massive Huaynaputina explosion in 1600, which dusted the skies with sulfur? Or could it have been a total solar eclipse where the moon perfectly blocked the sun's disk, leaving only a ghostly corona visible? What's striking is how the Inca responded. Unlike the Greeks who sought mechanistic explanations, the Inca saw celestial events as dialogues with the gods. Priests fasted and performed sacrifices, seeking to restore cosmic balance. The black sun wasn't just observed, it was felt, woven into rituals and prophecies. Even today, Quechua elders recount these stories, blending astronomy with spirituality in a way that challenges our modern separation of science and myth. This event reminds us that ancient sky-watching was never just about tracking stars, it was about deciphering the universe's whispers. And as we'll soon see, another culture halfway across the world would hear those whispers too, in the form of a celestial fire serpent streaking across the heavens. Now let's turn our gaze to the ancient clay tablets of Mesopotamia, where astronomers etched their observations of the heavens with meticulous precision. Among these records lies a puzzling reference to the planet of crossing, a celestial body that has sparked fierce debate among scholars. Was this the mythical Nibiru, a rogue planet said to cross Earth's path with catastrophic consequences? Or was it simply the planet Jupiter, whose looping retrograde motion baffled early skywatchers? The Babylonians, masters of celestial prediction, tracked Jupiter's movements with astonishing accuracy. Their cuneiform tablets describe its path as turning back against the stars, a clear nod to retrograde motion where a planet appears to reverse course in the night sky. But some researchers point to more enigmatic passages, speaking of a great star that crosses the heavens only once every few millennia. Could this be Nibiru, a world beyond our solar system, as some fringe theories suggest? Mainstream archaeology leans toward Jupiter. The Babylonians' advanced math allowed them to predict its retrograde cycles centuries in advance, and their term, Marduk, often linked to the planet of crossing, was a title for Jupiter in their pantheon. Yet the allure of Nibiru persists, fueled by modern interpretations of ancient texts and a longing for cosmic mysteries. What's undeniable is how these tablets reveal the Mesopotamians' deep engagement with the skies. Whether tracking Jupiter's dance or documenting an unknown visitor, their records remind us that humanity's quest to understand the cosmos is as old as civilization itself. And as we'll see next, this celestial curiosity took another fascinating turn in the lunar-solar calculations of the Druids. Shifting our focus from the clay tablets of Mesopotamia, we now journey to the misty forests of ancient Gaul, where the Druids crafted a timekeeping marvel, the Coligny calendar. Discovered in France in the late 19th century, this bronze artifact is one of the most sophisticated ancient calendars ever found, blending lunar and solar cycles with surprising precision. The Coligny calendar spans 5 years, divided into months that alternate between 29 and 30 days, a clear nod to the moon's phases. But here's where it gets intriguing. The Druids didn't just track time, they inserted extra months at calculated intervals to keep their lunar calendar in sync with the solar year, a technique eerily similar to modern leap years. This hybrid system suggests a deep understanding of celestial mechanics, far beyond simple ritual observance. Some scholars go further, proposing that the calendar's intricate markings might have been used to predict eclipses. Certain sequences of symbols align with the 18-year Saros cycle, a pattern ancient astronomers used to forecast when the moon would shadow the sun. Could the Druids, often dismissed as mere mystics, have rivaled the Babylonians in their astronomical prowess? Yet mysteries linger. The calendar's fragmented state leaves gaps in our understanding, and its purpose remains debated. Was it a sacred tool for timing festivals, a farmer's almanac, or an eclipse calculator? What's undeniable is its brilliance, a testament to the Druids' ability to harmonize the rhythms of the sky with the needs of earthbound life. As we'll soon see, this fusion of celestial observation and cultural practice takes another bold leap in the revolutionary models of Persian astronomer Nasir al-Din al-Tusi. Now, let's turn our gaze eastward to the golden age of Islamic astronomy, where a brilliant mind reshaped our understanding of the heavens. Nasir al-Din al-Tusi, a 13th-century Persian polymath, tackled one of astronomy's oldest puzzles, the erratic motion of the planets. His solution, a groundbreaking geometric model called the Tusi couple, a pair of rotating circles that elegantly explained why planets sometimes appear to loop backward in the sky. At the heart of this innovation was a simple yet profound idea. Imagine one circle rolling inside another, their motions perfectly synchronized. This clever mechanism allowed al-Tusi to simulate the retrograde motion of planets without resorting to the clunky epicycles of Ptolemy's ancient system. It was a mathematical masterpiece, blending precision with elegance, and it didn't just stop at theory. Centuries later, the Tusi couple caught the attention of none other than Nicolaus Copernicus. Scholars have long debated whether the Polish astronomer directly borrowed al-Tusi's work, but the similarities are striking. Copernicus used a nearly identical geometric device in his own heliocentric model, hinting at a possible transfer of knowledge from the Islamic world to Renaissance Europe. Was this the hidden bridge between ancient and modern astronomy? Yet al-Tusi's legacy extends beyond mechanics. His observatory at Maragha became a hub of celestial research, where astronomers refined star catalogues and challenged Aristotelian dogma. The Tusi couple wasn't just a tool, it was a quiet revolution, proving that even the most stubborn cosmic mysteries could yield to human ingenuity. As we'll discover next, this spirit of celestial inquiry wasn't confined to Persia. Across the globe, cultures were decoding the skies in ways that still leave us in awe. Shifting our focus to the land of the rising sun, we encounter a celestial event woven into the very fabric of Japanese mythology. The tale of Amaterasu, the Shinto sun goddess, tells of a time when she retreated into a cave, plunging the world into darkness, a story that eerily parallels an actual total solar eclipse recorded in 585 BC. Ancient chronicles like the Nihon Shoki describe this period of unnatural night where the sun vanished midday, leaving confusion and fear in its wake. Scholars now believe this wasn't just poetic symbolism but a real astronomical phenomenon. The timing aligns with geological evidence of a total eclipse visible over Japan, one so profound it may have inspired the myth of Amaterasu's withdrawal. What makes this connection fascinating is how the myth mirrors the eclipse's effects. Just as the goddess's absence disrupted life, historical records mention crops failing and social unrest during the event. The people's response, rituals to lure Amaterasu back, mirroring humanity's universal urge to explain and control the cosmos through story. This eclipse didn't just darken the sky. It illuminated how celestial events shape culture. While modern science demystifies eclipses, the Amaterasu myth reminds us that for ancient skywatchers, these weren't just astronomical events, they were encounters with the divine. As we'll soon see, this interplay of myth and cosmos repeats across continents, each culture interpreting the heavens through its own lens. Now let's journey even further back in time, to a site so ancient it rewrote history. Nestled in modern-day Turkey, the towering stone pillars of Göbekli Tepe stand as a testament to humanity's earliest fascination with the skies. Carved over 12,000 years ago, these massive T-shaped monoliths predate Stonehenge by millennia, and their intricate symbols might just hold clues to celestial secrets lost to time. Some researchers believe the animal carvings adorning these pillars aren't just decorative. They could be a prehistoric star map encoding the slow wobble of Earth's axis known as precession, a cycle that takes 26,000 years to complete. One theory suggests the vulture, fox, and scorpion motifs align with constellations as they appeared during the Younger Dryas period, a time of dramatic climate shifts. But there's another, more explosive possibility. Symbols resembling comets and flaming spheres have led scientists like Martin Sweatman to propose that Göbekli Tepe might document a catastrophic comet impact around 10,950 BC. This event, linked to global cooling and extinctions, could explain why our ancestors immortalized it in stone, a warning carved for future generations. What's striking is how advanced these carvings seem. Without writing or agriculture, the builders of Göbekli Tepe appear to have tracked celestial movements with startling precision. Were they ancient astronomers, or were they preserving a traumatic cosmic event? The pillars offer no easy answers, only tantalizing hints that humanity's relationship with the stars began far earlier, and with far more sophistication than we ever imagined. As we'll discover next, this blend of art and astronomy isn't unique to Göbekli Tepe. Across the globe, ancient cultures turned to the heavens for meaning, leaving behind puzzles we're still piecing together today. Now, let's turn our gaze to the vibrant world of the Aztecs, where celestial wonders were woven into the very fabric of myth and art. Among their most enigmatic symbols is the so-called fire serpent, a blazing creature depicted in the Codex Borgia, one of the few surviving pre-Columbian manuscripts. This vivid illustration shows a serpent engulfed in flames, its body studded with stars, an image that has sparked fierce debate among scholars. Could this be a record of a dazzling supernova, or perhaps a comet streaking across the heavens? The fire serpent's connection to Quetzalcoatl, the feathered serpent god, deepens the mystery. In Aztec cosmology, Quetzalcoatl was not just a deity of wind and wisdom, but also a celestial traveler often linked to Venus. Some researchers argue that the fire serpent's flaming tail mirrors descriptions of comets in other ancient cultures, while others propose it represents a supernova bright enough to rival the moon. One compelling theory points to the year 1456, when Chinese astronomers recorded a guest star, likely the supernova that created the Crab Nebula. Could the Aztecs have witnessed the same event and immortalized it as the fire serpent? What makes this interpretation even more intriguing is the Codex Borgia's precise astronomical details. The stars along the serpent's body align with known constellations, and its orientation matches celestial events visible from Mesoamerica. This suggests the Aztecs weren't just creating art, they were encoding astronomical knowledge, much like the builders of Göbekli Tepe. Whether the fire serpent depicts a comet, a supernova, or something even more extraordinary, it stands as a testament to humanity's timeless urge to document the sky's most awe-inspiring moments. As we'll soon see, this interplay of myth and astronomy isn't confined to the Aztecs. From the deserts of Egypt to the jungles of Cambodia, ancient cultures shared a common language written in the stars. Shifting our focus from the fiery skies of the Aztecs, let's step into the ancient landscapes of Europe and Mesoamerica, where stone and shadow reveal another layer of celestial mastery. First, we encounter the heel stone at Stonehenge, that towering sentinel standing just outside the main circle. For centuries, this massive slab has puzzled archaeologists and astronomers alike. But here's the fascinating part: during the summer solstice, the rising sun aligns perfectly with the heel stone, casting a long shadow that pierces the heart of the monument. Was this alignment intentional? Absolutely. The builders of Stonehenge didn't just stack rocks, they engineered a solar calendar with breathtaking precision. Some theories suggest it marked the start of harvest seasons, while others believe it guided ceremonial rites connecting the earthly and the divine. Now, leap across the Atlantic to the jungles of the Maya, where their zenith tubes tell a different but equally mesmerizing story. These narrow, vertical shafts built into temples like the observatory at Chichen Itza were designed to capture the sun's rays at specific moments, most notably when the sun passed directly overhead, a phenomenon known as the zenith passage. For the Maya, this wasn't just an astronomical event, it was a sacred signal. The zenith sun's appearance through these tubes likely marked the ideal time to plant crops, aligning their agricultural cycle with the cosmos. But there's more. Some researchers argue these tubes also tracked Venus, a planet central to Mayan mythology. Whether for farming or worship, these structures prove ancient cultures didn't just observe the heavens, they choreographed their lives around them. What ties these two marvels together? Both the heel stone and the zenith tube showcase a universal truth. From the misty plains of England to the steamy rainforests of the Yucatan, our ancestors saw the sky not as a distant void but as a living clock, a compass, and a calendar. And as we'll see next, this celestial dialogue between earth and sky echoes even louder in the star maps of the ancient Mediterranean. Now, let's turn our gaze to the ancient Mediterranean, where poetry and astronomy intertwine in a celestial mystery. Around the 3rd century before the Common Era, the Greek poet Aratus penned a work called Phenomena, a detailed guide to the constellations. But here's the puzzle: among the stars he described, one seems to have vanished without a trace. Modern astronomers have scoured the skies, comparing Aratus's descriptions to today's star maps, yet this elusive star remains unaccounted for. Some speculate it might have been a comet or a nova that faded over time. Others wonder if it was simply a misidentified star, lost in translation across centuries of celestial cartography. What makes this mystery even more intriguing is how precise Aratus was in his other observations. His descriptions of constellations like Ursa Major and Orion align almost perfectly with what we see today. So why would just one star go missing? One compelling theory suggests it could have been a variable star, a star that brightens and dims over long cycles. If it faded dramatically by the time later astronomers mapped the heavens, it might have slipped through the cracks of history. Another possibility: a transcription error in later copies of Aratus's work, altering the star's position or name beyond recognition. The search for this lost star isn't just about solving an ancient riddle, it's a window into how knowledge evolves. Aratus's Phenomena was a bridge between myth and science, blending poetic imagination with keen observation. And while we may never know the fate of his missing star, the quest to find it reminds us that even the most meticulous records of the past can hold secrets waiting to be rediscovered. As we prepare to delve into the next mystery, consider this: the stars that guided ancient poets and navigators are the same ones we study today, yet their stories are still being rewritten. Now, let's journey from the lost stars of ancient Greece to the celestial wisdom of the Hindu tradition, where the night sky was mapped with remarkable precision. The Hindu nakshatras, a system of 27 lunar mansions, served as both an astronomical guide and a spiritual compass in Vedic astrology. Each nakshatra corresponds to a specific segment of the moon's path, dividing the sky into equal parts, much like the Babylonian Zodiac, but with a uniquely Indian perspective. What makes the nakshatras fascinating is how deeply they were woven into daily life. Unlike Western astrology, which focuses primarily on the sun's position, the nakshatras tracked the moon's journey, linking its phases to rituals, agriculture, and even personal destiny. For example, the nakshatra called Rohini, associated with the star Aldebaran, was considered auspicious for planting crops, while Ashwini, tied to the stars Beta and Gamma Arietes, was believed to favor healing practices. The parallels to Babylonian astronomy are striking. Both cultures independently developed systems to divide the ecliptic, the sun's apparent path, into segments, using them to predict seasonal changes and celestial events. But while the Babylonians focused on 12 zodiac signs tied to solar months, the nakshatras emphasized lunar cycles, reflecting India's reliance on a lunisolar calendar. Some scholars argue this similarity hints at ancient cross-cultural exchanges, while others see it as evidence of humanity's universal urge to find meaning in the stars. One of the most intriguing aspects of the nakshatras is their enduring relevance. Even today, they play a vital role in Hindu weddings, naming ceremonies, and festivals, proving that these ancient sky markers are more than just historical curiosities. They're a living tradition. As we turn next to our final mystery, remember this: whether in Greece, Babylon, or India, the stars have always been more than distant lights. They are storytellers, timekeepers, and guides. Now, as we reach the final entry in our journey through ancient celestial mysteries, let's step back and marvel at the bigger picture. The Star of Antiquity isn't just one event, it's a symbol of all the unexplained phenomena that captivated our ancestors. Across cultures and millennia, skywatchers recorded strange lights, sudden darkness, and wandering stars that defied explanation. What's remarkable is how many of these accounts align with real astronomical events, yet some remain puzzles even today. Take, for example, the Greek historian Plutarch's description of a night that turned to day, or the Chinese records of guest stars that appeared and vanished without warning. Modern astronomy can explain many of these as supernova or comets, but others, like the Babylonian observations of planets moving in erratic patterns, still challenge our understanding. These anomalies remind us that ancient astronomers weren't just myth-makers. They were meticulous observers, often working without telescopes or precise instruments, yet detecting cosmic oddities that science is still unraveling. What ties these mysteries together is the human impulse to document the unknown. Whether carved into clay tablets, painted on temple walls, or passed down through oral traditions, these records reveal a shared curiosity about the cosmos. Some theories suggest ancient civilizations might have witnessed rare events like gamma-ray bursts or rogue comets that modern astronomers have never seen. Others propose that gaps in our knowledge, like the lost star catalogues of Hipparchus, hold clues to forgotten celestial phenomena. As we close this chapter, remember this: the stars that guided ancient navigators, inspired myths, and sparked debates are the same ones we study today. The difference is, we now have tools to probe deeper into their secrets. Yet, the fact that some ancient observations still stump us proves how much there is left to discover. The sky hasn't changed, but our understanding of it is always evolving. And who knows, perhaps the next great astronomical breakthrough will come from revisiting these age-old mysteries with fresh eyes. With that, we've reached the end of our 50 enigmatic events, but the conversation is far from over. which of these ancient celestial wonders intrigued you the most? Let us know in the comments below, and don't forget to like, subscribe, and hit the notification bell so you never miss a journey into the mysteries of our universe. Until next time, keep looking up, but before we wrap up, let's take one last fascinating detour into a cosmic event so dramatic it left its mark across the entire planet. Around the year 540, something extraordinary happened. A mysterious veil of darkness descended over Earth, chilling summers and dimming the sun for months, even years. Tree rings from this period tell a startling story. Across continents, from Ireland to Siberia, growth rings suddenly narrow, revealing stunted growth during what should have been thriving seasons. Meanwhile, ice cores drilled from Greenland and Antarctica show a spike in sulfuric acid, a telltale sign of a massive atmospheric disturbance. So what caused this global twilight? One leading theory points to a comet fragment exploding in Earth's upper atmosphere, scattering dust and debris that blocked sunlight worldwide. Ancient chronicles from Rome to China describe eerie skies, suns that shone without warmth, crops failing under ashen haze, and even reports of bluish moons. The Byzantine historian Procopius wrote of a year without summer, while Irish records speak of bread failing from the heavens, possibly referencing famine caused by the climatic shift. What makes this event so compelling is how it bridges myth and science. Some scholars link it to the Arthurian legend of the death of Merlin, where the sky darkens as a harbinger of chaos. Others tie it to volcanic eruptions, but the global tree ring and ice core data suggest something more extraterrestrial. Could this have been a smaller-scale version of the asteroid impact that wiped out the dinosaurs? The evidence leans toward a cosmic culprit, though the exact nature of the object, comet, asteroid, or even a swarm of space debris remains hotly debated. This cataclysm wasn't just a celestial spectacle. It reshaped human history, triggering migrations, wars, and societal collapses as crops failed and temperatures plummeted. Yet it also underscores how interconnected our planet is with the cosmos. A single fragment from the depths of space, invisible until it struck, altered civilizations from Europe to the Americas. And that's the real wonder here. The universe doesn't just inspire stories. It writes them, sometimes in ice, sometimes in tree rings, and always in the lives of those who witnessed its power. So as we close this journey through ancient astronomical mysteries, let's remember, the sky has never been a passive backdrop. It's an active player in our story, capable of turning history with a single, silent strike from the void. Thanks for joining us on this exploration. If you've enjoyed unraveling these cosmic enigmas, don't forget to like, subscribe, and keep looking up. The next great mystery might be written in the stars above us right now. As we bring our journey through these 50 ancient astronomical mysteries to a close, let's take a moment to reflect on just how much these celestial puzzles have shaped our understanding of the cosmos. From the Star of Bethlehem to the global darkness of 540, each event reminds us that the sky has always been more than just a canvas of light. It's been a source of wonder, fear, and relentless curiosity for every culture that gazed upward. What's truly remarkable is how these ancient observers, armed with nothing more than their eyes and ingenuity, laid the foundation for modern astronomy. The Babylonians tracking Venus, the Maya predicting eclipses, the Greeks mapping wandering stars. They were the first scientists, turning myth into math and mystery into knowledge. Their legacy isn't just in the artifacts they left behind, like the Antikythera Mechanism or the Nebra sky disk, but in the very questions we still ask today. Some of these enigmas may never be fully solved. Was the star of antiquity a supernova, a comet, or something even stranger? Did the Dogon truly know about Sirius B centuries before telescopes? These gaps in our understanding aren't failures, they're invitations. Invitations to keep exploring, to keep questioning, and to remember that the universe still holds secrets older than history itself. So now, we'd love to hear from you. Which of these 50 mysteries captivated you the most? Was it the eerie precision of the Choco Canyon sun dagger, the haunting predictions of the Hopi blue star, or something else entirely? Drop your thoughts in the comments below. Let's keep the conversation as alive as the night sky that inspired it. If you've enjoyed unraveling these cosmic riddles with us, don't forget to hit that like button, subscribe for more deep dives into history's greatest puzzles, and ring the bell so you never miss an adventure. The universe has been writing its story for billions of years, and as today's sky watchers, we get to read it one mystery at a time. Keep looking up.